In this video, I'm going to go over some basics of Coulomb's law. So, according to Coulomb's law, the magnitude of force of attraction or repulsion between any two charges, let's say charge Q1 and Q2, at rest, and they are separated from each other by a distance r, the force is directly proportional to, so let's say F is the force. So force is directly proportional to the product of the magnitude of the charges. So let's say Q1 and Q2. And inversely proportional to the square of the distance between them. Therefore, the force can be written as proportional to Q1 Q2 over r square. Or we can write it as, we can replace the proportionality sign with the equal sign and introduce a constant which is known as Coulomb's constant or electrostatic force constant, let's say K. So Q1 Q2 over r square. The value of this electrostatic force constant depends on two different factors. One of them is the system of units used. The system of units used. So either SI unit, let's say CGS units, there are different units, system of units. The second thing it depends on is the nature of the medium. Nature of the medium. So the nature of the medium in which these charges are placed. Can be space, can be water, I don't know, can be anything. So in SI units, let me write down the value of K. In SI unit system, K is equal to 1 over 4 pi epsilon. And this epsilon can be break down into 4 pi epsilon naught times epsilon r. Now here, this epsilon naught is called the absolute permittivity of the space, and the value of epsilon naught is equal to 8.854 into 10 raised to power negative 12 Coulomb square Newton inverse meter square inverse. So it's called absolute permittivity of free space. Let me write that down. Absolute permittivity, I think double T, permittivity of free space. And epsilon r is the relative permittivity of the medium. Relative permittivity of the medium in which the charges are placed. And the relative permittivity has no units. It is just a number, like a pure number, no units. So in SI, so we can say in SI unit system, Coulomb force or the electrostatic force by Coulomb's law, it can be written as 1 over 4 pi epsilon naught epsilon r into q1 q2 over r square. In free space, the value of epsilon r is equal to 1. Therefore, the force can be written as, gonna insert epsilon r equal to 1. So the value of F is 1 over 4 pi epsilon naught into q1 q2 over r square. So that's the force between two charges according to Coulomb's law. And the value of this constant, this part, 1 over 4 pi epsilon naught is equal to 9 times 10 raised to power 9 Newton meter square per Coulomb square. So using this equation, the magnitude of electrostatic force between 2-point charges q1 and q2 separated by a distance r in free space can be calculated. Okay, so this formula basically gives you the force in a medium with the relative permittivity epsilon r. So let me write r over here, and this is the force in free space because epsilon r is equal to 1. So if we compare or divide these two, let's say this is equation 1 and this is equation 2, and if we divide them, that gives us the value of epsilon r, which is going to be force in a free space between those two charges over force in a medium between those two charges. So we can find the value of epsilon r.